Yeah, so I'm Kerry Osbourne. Thanks for coming to listen to me. I'm going to talk a little bit about something that I've talked about quite a bit in the past, actually, and it's a technique for controlling execution plans inside of Oracle. There's a bunch of ways to do it, and so I'll kind of go through the options. What else should I tell you? I'm kind of an old Oracle guy. I'll introduce myself a little bit. But basically what I'm going to talk about is how to do magic with Oracle execution plans without having to actually get to the code, which can be problematic. So who am I? I'm an old Oracle guy. I started with version 2. So for those of you who don't know, that was the first commercial version. And so when I was still in college, actually, my first job, I got handed a set of Oracle manuals, and they said, we got this new thing, we don't know much about it, go figure it out. So back then we had no idea what a relational database was really going to be like, and we had eventually Sybase and Ingress and all these other things. And it just turned out that Oracle was the one that did best, so I just was lucky that that was the one I started with. I worked for a little company called Incotech. It's been acquired now by Accenture. It's a real small group of guys. Mostly very high-level guys that are kind of spread around the world. We actually have 3 guys here in Sao Paulo. So Alex Zabala is actually one of them, and then there's a couple other guys sitting up here in the front that work here. I'm not really certified in anything. I never worked for Oracle. I've always been an independent guy. I do really like Exadata. I've done a lot of work on Exadata over the last several years. I'm kind of a performance-oriented geek kind of a guy. And when Exadata came out, it was really cool. And so we got really interested in it and did a lot of work with it. I'm also kind of into Hadoop right now. We're getting drugged that way on our data warehouse stuff increasingly. And so that's another topic that I'm very interested in. Incotech has a bunch of equipment. We have a bunch of Exadatas and VDAs and Exalytics and all kinds of things in our lab, which gives us a big advantage in terms of research and stuff. So anyway, I'm in a couple little clubs. I've worked on a couple of books, and that's where my blog is. So if you want to find out stuff, and in fact, these presentations are up on the blog now, so if you want to download them, they're there. Okay, just to get started, I really like the VDA because it's got a top secret feature. It's a beer shelf that's built into it. Actually, this is the old version. The new versions don't have it anymore, so I like the old retro stuff myself. Okay, so what's the point of this presentation? An awful lot of performance issues that we have in Oracle are related to execution plans. The SQL language really specifies what we want out. It doesn't really specify how to get it out, and so the optimizer inside Oracle is the piece of code that tries to figure out how to get the data out, right? So a lot of times when we're having problems with Oracle, it's because the execution plan is not the best that we could get. And so there's many techniques that we can use to try to get better execution plans. It doesn't necessarily have to involve changing the SQL itself. And so we're going to talk about some of those. So before I get started, how many of you know what a SQL profile is? All right. Raise your hands higher because my eyesight's not so great. Okay, good. How many of you have actually used SQL profiles before? Okay, many of you. How many of you used the SQL Tuning Advisor to generate those profiles? Okay, many of you. How many of you have ever heard of a SQL patch? Anybody ever used a SQL patch? Okay. What about baselines? How many of you are using baselines? Okay. How many of you actually that are using baselines turn capture on your systems? Okay, a couple of you. All right. Anybody ever used an outline? Anybody ever even heard of an outline? Okay, so you guys are old guys, right? Or you're working with really old versions of the database? All right, so those objects that I just mentioned are all objects that we've got in the database that allow us to do some processing behind the scenes via hints of SQL statements. So that's what I'm going to talk about. This is a two-part discussion because it's too long to get into 45 minutes. So I'm going to talk for 45 minutes, and then I'm going to leave you hanging. And then if you want to hear the conclusion of how the whole thing actually turned out, you'll have to come back and listen to me after lunch. So I apologize for that, but it's kind of like a TV series where they leave you hanging at the end of one episode, and you have to watch the next episode to see how it turns out. All right. So these techniques, in some cases, can provide instant relief for us, and it's very close to magic. If you're okay. So why do we have bad plans? Well, as you know, the optimizer is very complex. All right. So it's probably one of the most complex pieces of code in existence, actually. It's trying to figure out how to go about getting data from a database, right? So it's some of the queries that we pass it. Some of the queries that we pass it are really complex, right? You guys have probably seen some of these, 10-page long queries, right? So imagine how complicated the optimizer code's got to be to figure out all that stuff and then figure out how to go get it, right? So it is really complex. Generally speaking, we don't understand it well enough. Most of us don't. There are a few, geniuses in the world like Karen Morton and Jonathan Lewis and guys like that, right, that really understand it really well. But most of us have a decent understanding of it, but we don't really understand all the complexities of it. Sometimes the code is bad. The code itself. Sometimes the SQL statements are not good, not constructed properly. Sometimes, quite often, we don't have really good statistics, right? Sometimes we either inherit or choose ourselves to set some of the optimizer-oriented parameters in the database in a way that's not the most effective, right? A lot of times they're set before we got there, and everybody's too afraid to change them, right? So sometimes we have to deal with things that are not great on that standpoint. And actually, the optimizer is not perfect, right? The guys that are writing the optimizer are constantly trying to improve it, constantly adding new features and trying to fix old bugs, right? So there are things that the optimizer is just not smart enough yet to know how to do, and there are things that it tries to do, and sometimes it's too clever for its own good, right? So you guys have probably experienced some of those situations, right, when a new feature comes out. So when it's too clever for its own good, sometimes we just have to work around those issues, right? All right. I'm going to skip through this. We do have, I mentioned this already, but SQL is a very high-level language, right? So we don't really tell, generally speaking, we don't really tell the optimizer how to go about its job. We just tell it this is what we want. We do have hinting mechanisms that will allow us to be much more specific about what we want the optimizer to do. Generally speaking, the recommendation is not to try to control it to that level. And the reason is because the optimizer is pretty smart, right? And oftentimes if we try to hint it ourselves, we're not going to do a good job of it, and certainly are not as knowledgeable as the guys writing the optimizer code are, right? So generally speaking, we try not to hint things unless we can avoid it. But basically, it's just a result set that we're trying to define. I will point out that the number of parameters just keeps going up and up and up. So there's over 3,000 in 12C. And many of those, affect how the optimizer itself works. So the number of combinations are just like almost infinite, right? So it's very difficult to deal with that sometimes. So generally speaking, sometimes when you do a SQL statement, it seems pretty simple to you what you want, but it's giving instructions to your kids. Sometimes you just say, I want you to go across the street. The path the kid takes might not be as straightforward as you might expect, right? So sometimes you have to help. All right, so why can't we just fix the code ourselves if it is a code problem? Packaged applications, like if you're running PeopleSoft or you're running SQL, you don't really have access to the code itself, right? So you can't go and make changes. You can't put a hint, for example, into a SQL statement to make it behave the way you want it to because you don't have access to the code. You have to notify the manufacturer, ask them to fix something, 3 months later, maybe they give you a patch, right? So that sometimes is very difficult to do. Sometimes there's not enough time. You've got an emergency situation, for example, right? I had a situation, I'll tell you a story about a situation where we were at a customer that was actually a phone provider, a telephone provider. And they had a screen that basically had a whole bunch of fields on it, and you could fill in any set of fields that you wanted, and then it would dynamically create a query behind that, and it would go through this data warehouse and pull back a report of the data that you asked for. Right? So at some point, the system pretty much stopped working, and the customers couldn't get their data back. So they had like a 2-minute timeout. After 2 minutes, the query would stop, or the application would stop waiting for the results, and give them a chance to query it again. Unfortunately, they didn't actually kill the query, so if they started a query that was going to run for 6 hours, they would let the users issue it again, even though the other one was still running, right? But they were never going to get the results. But anyway, when we looked at it, what we found out was they had a date range, and that was the most important sort of criteria on that report. And they had written this application in Java. The variable that they used for that time, for that data, that date field, was not a date type compatible, right, with Oracle. So what happened was the Oracle optimizer was saying, hey, that's a character string, that's not a date. So therefore, I have to put a to-char function around my date field, which meant it disabled any indexes on that field, right? So basically, it was having to do a full scan of this big, huge table every time they executed it. So anyway, the answer was, the synopsis that we gave them was, hey, if you just change your variable type, or if you're not smart enough to do that, just put toDate, around that variable, and you'll be fine, right? So basically, they needed to add 8 characters to the application. And so I was in a meeting with everybody from the CIO all the way down. So there's this huge meeting, right? Not as big as this one, but pretty big. And so the CIO looks at the program director, and he looks at the manager, and the program manager looks down the line. Eventually, they get to the poor little developer lady that's sitting in the corner, right? And they're like, how long is it going to take to get those 8 characters into the code? And she says, 3 months. And then a big argument ensues, and eventually they agree on 2 months, and it takes 2 months to get it in. And the reason is because they had such onerous change control procedures that they just couldn't figure out how to get an emergency fix put into the code. Right? So sometimes we have that sort of a thing. And so the techniques I'm going to talk about are ways to make changes almost instantaneously with very little risk and make you look like a magician, like a wizard. All right, predictability. Remember back in the good old days, how many optimizer? Right, we had a rule-based optimizer, statement, execute. Right, so it was very predictable. I never had to worry about putting in on money, and all of a sudden everything had gone bad because the optimizer changed its mind. In version 7, that's when we got the optimizer for the first time, the cost-based optimizer. Want to try that one? This better? Okay, we're back to the good one. All right, so in 7 we had the cost-based optimizer. Almost immediately, when 8 came out, we had a thing called the plan stability feature. The plan stability feature was actually outlines. So if any of you have heard of outlines, that was the first attempt to create stability in plans, right? Because in 7 it was very unstable. And in 8, they came out with outlines to say, I'm going to put some hints behind the scene to try to force or lock a specific plan. So they've been very aware from day one that this cost-based optimizer can create instability in plans. There are some features too that they've added that contribute to instability. Cardinality feedback being one of them that you see get turned off fairly often. It's a great idea, right? The idea is if I come up with an execution plan and the optimizer thinks on a certain step that my cardinality is going to return 1,000 rows and it returns 3 million, the optimizer should be able to figure that out and in subsequent executions come up with a better estimate, right? So that's what cardinality feedback is all about. And it's a great idea. It's just when it was first implemented, it was a little buggy. And it's much better now, but it definitely has created a lot of instability when they first introduced it. Of course, stats, changing can also create instability. And then there's, the favorite long-time nemesis, bind variable peaking, which is actually also much better in 11. 11's got adaptive cursor sharing, which improves the situation significantly, but certainly in 10, you'd peek at the bind variables, get a plan, and then you'd be stuck with that plan until it got flushed out, right? So if you had skewed data, and in some cases you'd want to use an index, and in other cases you'd want to use a full scan, you could only have one or the other, right? So a full scan would be consistent, but if you happen to pick up an index on something where you're getting most of the data back from the table, then it could be horrendous from a performance standpoint. So bind variable peaking causes lots of problems. Any questions about that? Anybody had to deal with bind variable peaking in the past? Got to raise your hands high. Yeah, a few of you, okay. So yeah, just a digression. It's I'm not sure really whether it's a feature or a bug. If you just put a jacket on the bug, it kind of looks like a feature, but I didn't really think bind variable peaking necessarily was a feature. Anyway, so the improvements in 11 and 12, this adaptive cursor sharing thing helped a lot, right? And what it does is it tries to notice that, hey, I've got two different plans here that might work, right? The problem with it is that it doesn't notice until it's run really badly at least once, right? So in general, 11 doesn't suffer too much from it because most of our systems tend to stay up for long periods of time, and it settles down pretty quickly once you start running queries, right? But you do have to run the query at least one time badly before it will notice. And if you have something like, heaven forbid, you shut the database down every night, or your shared pool is undersized so stuff's getting flushed out all the time, then this is not going to help you much because every time the query gets flushed out, it's going to have to rediscover that you got this situation, right? So you could still suffer from it in 11 in those cases. Okay. But it is smart enough to know that multiple plans need to exist, and it can have multiple plans for the same SQL statement and pick the right one. As I said, the bind sensitivity is not persisted in 11, though. In 12, it even will get a little bit better, I think. It attempts to fix it on the fly, so even the first time you go through a query, if it thinks it's going to be good to use an index because it thinks it's going to get a relatively few number of records, and then it finds out, hey, I'm getting way more than I thought, it'll bail out on that index plan and go to a full scan plan automatically the first time through. Okay, so that's called adaptive optimization. So if you thought this instability stuff was scary before, imagine what it's going to be like when the optimizer can change his mind in mid-execution. Okay, so this is a little bit scary early on, but I think eventually, I think the concept is right, and this is what we want to do. But you know how Oracle is, and usually it takes a little while to settle things down. So, but eventually, I think we won't have any bind variable peaking sort of issues because of this. And it attempts to persist that information so that, when you bounce the database, you don't have to rediscover it the next time. All right, so on to the main topic of this thing. So if we have plan instability or we're getting bad plans, there's several things we can do to address it without having to touch the code, right? One thing is we can change the parameters. So if we have index cost adjust and some of those funky parameters set to funky values, we can turn the knob, to make Oracle favor indexes or favor full table scans. That's one thing we can do. We can also add additional indexes. If I'm getting full scans and I need to have an index path, I can do that. I can also remove indexes. If I'm getting an index on a particular query and I want to do a full scan, I could remove an index. I can monkey with the stats. So if I'm not getting the plans I want, maybe the stats are not accurate enough. I can also do things like manually modify the statistics to what I want them to be to fake Oracle out and to making him, think something's true even if it's not necessarily true to get him to pick the plan I want. The problem with those things, what do you think the problem with those things is? All those things. One common problem with them. Now I'm going to wait until somebody says something. By the way, I like people to ask me questions while I'm talking. I don't like to just talk and have people stare at me. It's kind of weird. Anybody got any idea what's the common theme with those things? Yeah, perfect. The guy said it may affect other queries. Right? Any one of those options could have a really wide-ranging effect. If I change database parameter, it could potentially affect every query in the system. Right? Same thing with adding indexes or removing indexes. Just because I got one query I want to fix, this is a big hammer, right? All these things are big hammers. They're not going to affect just one query. They're going to affect potentially hundreds or thousands of queries. Okay? So very risky, requires a lot of testing. In some cases, if we've got really bad database parameters and everything's running bad, then you have to address it. But if it's a single query that you're dealing with, you don't really want to be trying to do it with these big knobs. Right? Everybody agree with that? Okay. All right. Or we can use some of these techniques that I'm going to talk about now. So the idea with these techniques is all to use hints for a single query behind the scenes. And there's basically 4 options as of 11G. I've already mentioned all 4 of them. Outlines is the one that came about in version 8 that I hope nobody's using at this point. Profiles came about in version 10, as did SQL patches, I think. And then baseline showed up in 11. Okay. All of them had different goals, so they weren't really all designed to do the same thing, but they all use the same basic mechanism. Okay. They each apply a set of hints to a single SQL query behind the scenes, so that the optimizer can use those hints, but you don't have to change the code to include those hints. Make sense? And every time they add a new one, they add something new to the mix. So just to be clear, these are not plans. All right, so baselines do not store plans for a SQL statement. It's, when you read the documentation, it looks kind of like that, it's a plan that they're storing. It's not a plan. All right, it's just a set of hints. So hopefully that set of hints is complete enough to limit the optimizer's choices down to a single plan. But as you can imagine, if you've got a SQL statement that has thousands of lines in it, it's quite possible that the set of hints that Oracle thinks might limit to a single plan may only cut down the choices to a handful or 10 or 100 even, right? Right? Does that make sense? It's very difficult to come up with a set of hints that will lock a statement that has thousands of lines in it down to a single plan. They're each assigned a name. They can be attached to a single SQL statement. So I don't have the problem of being such a big hammer, affecting a bunch of stuff. In some cases, we can assign them to a set of SQL statements with profiles. Profiles have the ability to apply to statements that match everywhere except for literal values. So if I had a data warehouse, for example, where I'm using literals in my queries, I can apply a profile to a set of queries that just have the literals changing and nothing else. Make sense? I'm going to repeat, these things do not lock plans, although they can come really, really close, and in many cases, virtually they lock plans, but it's not a plan, it's a set of hints, okay? All right. So where do you think these sorts of things would work well? Do you think it would work well if your whole system is like not working well and all the plans are bad? Probably not, right? Because number one, you don't have time to create these things on every single SQL statement, right? That would be very onerous. So if you have a few statements with bad plans that you're trying to fix, these things are really, really handy. These are not, good for systems that are not set up well. They're just behaving badly across the board, right? So don't go out after you listen to this presentation and create 3,000 SQL profiles on statements. I do not want to show up at your site someday in the future and find out that Kerry said to create profiles, and so now we have, 10,000 of them, right? All right. They work good if you're having plan instability due to bind variable peaking or any other sort of reason. They work sometimes really well for shortcomings in the optimizer. So like in version 10, the optimizer didn't know about correlated columns and was never going to know about correlated columns. So in those cases, having some way to help give that information to the optimizer could be helpful, and these can be good for that. I think you should think of them as Band-Aids, okay? There are ways to very quickly change an execution plan, but in most cases, they're not something that, you want as a long-term solution. Note that they can have laser-like specificity, which is a really big word, but I mean just specific to a single SQL statement. I know it's a big word, but anyway. So where don't they work well? Anywhere there's lots of problems, already told you that, lots of statements that have bad plans, systemic kind of problems. They also don't work well if you have things where the structure of the query needs to change. So if you have something that looks like a bunch of union alls that really should be an in clause, that's really difficult to change with hints, unless you can get it some sort of transformation to kick in the back end. But generally speaking, changing the structure of the query is difficult to do with hints, so it doesn't work well for that. Is that clear? There is a new thing in 12 called the SQL translation framework that's going to allow us to change any SQL statement, something like that, and rewrite it on the fly. So we'll be able to basically rewrite SQL statements behind the scenes. Well, we can in 12 now. It's a little scary because you don't even have to use the same tables. You can basically rewrite any SQL statement to run any other SQL statement. Okay? So if you give that a little bit of thought, imagine what kind of havoc you can wreak with that. I'll do a presentation on that someday. All right, so the next bit of this is to talk about the various options we've got and sort of the pros and cons of them. I won't talk about outlines much because I don't want you to use them. And how much time do I have, actually? Anybody know when I'm supposed to stop? 11:35. Okay, so I got only 10 more minutes. All right, so I'll give you briefly sort of the pros and cons of the outlines, profiles, and baselines, and then we'll break, and then you have to come back for the rest of the story later. So stored outlines. They're half-baked, I said originally, but not really even half-baked. The goals to lock plans. There's a whole bunch of stuff about them. You can read it in the presentation later, but I don't want to talk about them because I don't want you to use them. Okay. The only reason you might use them is if you have standard edition, or if you're on a really old version of Oracle. Okay? And they've been deprecated for a while, actually, but they do still work. Okay? So SQL profiles. SQL profiles are, I would say, 3/4 baked. The goal of SQL profiles was not to modify execution plans, not to allow you to modify execution plans. All right, the goal was to apply statistical fixes, and by that I mean that cardinality stuff that I was talking about, right? So if you have a single line in a plan where the optimizer thinks I'm going to get one row and you're really getting a million rows, SQL profiles were designed to give the optimizer that information. They did it via a hint that was applied behind the scenes, but that was the goal. And they were designed to be created by the SQL tuning advisor. They were never designed to be manually created and then used. All right. They use this semi-undocumented opt-estimate hint. The opt-estimate hint basically just applies a scaling factor to individual lines in an execution plan. So again, if the optimizer thought it was going to get one row and it was 1 million, it would be a scaling factor of 1 million, and it would just multiply whatever Oracle came up with as a cardinality estimate for that line by the scaling factor. All right? So that ought to give you some idea about a SQL tuning advisor generated SQL profile. What do you think is going to happen if you generate one of those and it magically fixes your plan but then you later gather statistics and things have changed in your data distribution. I think that scaling factor might now be off because now it's got new statistics and the estimate that the Oracle optimizer comes up with might be different. Yeah, that happens pretty often. So you have to be careful with these things. These things are also good for as a Band-Aid. They're definitely not good to leave in place for a long time. Invalid hints are going to be ignored silently. So if you had an index hint or something in one of these and the index gets dropped, it's not going to give you an error. It's just not going to be able to use it, right? They're stored in the same place that baselines are inside the data dictionary. There is a procedure to import these things manually. It's called import SQL profile. It's run off the screen, but which is kind of cool, and I've got an asterisk because that's an important concept that we'll come back to. They're capable of applying any valid hints. As far as I know, I haven't run into one that I couldn't apply with one of these. So there may be one, but I haven't run into one yet. They use this concept of categories. The default category is called default. So if you create one and you don't set a category, the whole database is going to use it whenever that SQL statement gets executed. If you want to test, you can create one in a different category and then do an alter session. So if you're working in a production system, for example, and you want to test a profile out, you can create one in the test or the Kerry category, and then only sessions that have that set in their session would see it, right? And then if it worked, then you could change it to default, and then everybody would pick it up. Tom had something to say about the statistical nature of these things. You can read that later. I'll show you what the opt estimate looks like real briefly. It's probably too small to see, but it says opt estimate. It tells you where in the plan it's a join on table F and B, and it's got a scale factor. Scale rows equals 26. All right, so that's not a very big change. This one up here is e to the negative 8. So that's a really, really big decrease. In this case, the optimizer thought, it had 1 million rows or 1 billion rows, and it really was like 1 or 2, right? So that's basically what it looks like. So again, I'm going to warn you about this. I'm not really a big fan of the tuning advisor. Many of you raised your hand on the tuning advisor. There's good things and bad things about it. The good thing about it is it can often help you find a much better plan. The bad thing about it is if you accept a SQL profile generated by the tuning advisor, it has that opt estimate hint in it, and those things over time, can get pretty bad, right? They tend to sour over time, is the way I would describe it. Like I said, they can help you find plans, if the optimizer is struggling, and there are other techniques that we'll talk about for locking those things in once you get them, eliminating that opt estimate hint, but locking in a more directive kind of a set of hints that will keep it in place. Make sense? All right. And occasionally they're good for things like the correlated columns thing that I mentioned, right? If the optimizer is always going to underestimate on a particular thing, then that scaling factor may be okay for a long term, right? But you have to really know what you're doing to know whether that's the case or not, right? So, anyway, I think they tend to sour over time, and I don't like them because of that. And I will tell you, I've been to several customer sites where they were having problems with a lot of SQL statements performance-wise, and when we got to looking at it, we found that all the ones that they were having problems with were ones where they'd used the SQL tuning advisor to generate profiles, a couple of years ago. And so as the data had changed, those plans, the scaling factors didn't make sense anymore, and so they were actually screwing up the plan of those statements, right? And so the fix was pretty much just drop or disable the SQL profiles that have been created with the tuning advisor. So just be aware of that. Make sure that you're paying attention when you're doing that. It's kind of like what I told you about creating SQL profiles in general, right? I don't want to show up and see 1,000 of them there, because generally speaking, they're better as Band-Aids, not as long-term fixes. And the documentation acknowledges that issue as well. I'm going to skip over that. I will mention this import SQL profile is a way to manually bring in your own hints. So It's a set of 2,500 character long hints that you can bring in and create your own SQL profile with. So if you decide that you want to, make use of this technique, I've written some scripts and they're available on the blog to do this with. This is a way to create your own object that does that. Okay, we'll come back to that later in the second half. It is part of the tuning pack, by the way. So if you're not licensed for the tuning pack, then you're not licensed to use this technique. Okay. I've got 5 more minutes. I'll run through patches real quick, and then we'll leave baselines till this afternoon. And nobody's ever heard of SQL patches? Anybody heard of SQL patches? Okay. SQL patches is basically, the goal was to modify plans to avoid errors. So they're designed to be created by the repair advisor. So if you ran a SQL statement and got an error, sometimes, it could be an optimizer error, and sometimes you could avoid it by applying a hint to say, don't do that thing, whatever that thing was. All right, so that's what it was created for. They are enabled by default. They don't apply to multiple statements, only to a single one. The invalid hints would be silently ignored. They're stored in the same place. There is a procedure to import manual if you want to, not use the repair advisor, but actually create one on the fly on your own. So I have a script, for example, that says, give me a SQL ID and type in a hint, whatever hint you want to apply to it behind the scenes. Right? And it uses a SQL patch. So it's pretty cool. They did show up in 10, but they were kind of funky in 10. Probably better used in 11. You can do any valid hint. They do use categories. You can apply one of these things even if you're using profiles or baselines. They just merge the hints. Okay? And basically, the way I would describe it is it's like a one-hint SQL profile. All right, so SQL profile, I told you, could have 2,000 lines of hints that are 500 characters. This is basically just one line. You still could have multiple hints in it, whatever would fit in the 500 characters, but it's only one line. Maria Kogan actually did a really good blog entry on them on the Oracle blog, on the Oracle Optimizer blog. So there's a link to it. Okay. I was told to have 10 more minutes, so I think I might jump into baselines too real quick. But here's just an example. I told you that the hints could be merged. You could actually have, this is DBMS XPlan output on a statement. And down in the notes section, notice I've got a profile, I've got a patch, and I've got a baseline. I don't know if you guys can read that from that far away, but basically all 3 of these things have been applied to this particular SQL statement. And basically the way it works is it's a merger of the hints in those objects. Okay? All right. Let's talk about baselines real quickly, and then we'll break for lunch. Baselines are almost fully baked, I think. Right, and the reason I say that, well, let me tell you about the goal. So the goal was to prevent performance regression. Right? The goal for baselines was not to lock plans. The goal for baselines was to not allow the optimizer to come up with a new plan that performed worse than one I've already got. All right? So it's a performance regression prevention feature. So goal is basically closer to what outlines was than it is to SQL profiles or SQL patches. They're turned on by default. They're capable of applying any valid hints. Here's the big difference. They have an associated plan hash value. So baselines know what they're trying to accomplish. Right? Profiles, outlines, and patches, they don't have any idea. All they know is there's a set of hints. They're going to apply them when the optimization is done. And then whatever plan they come up with, they're going to run it. All right? That can be a good thing and a bad thing depending on your point of view. Right? If baselines, and we'll have to postpone some of this discussion after lunch, but baselines, they know what the plan hash values they're trying to get. So if they apply all those hints and they don't get this plan hash value, they throw all the hints out and they go with the default optimization with no hints. All right, let that sink in for a minute. What that means is baselines are pretty much all or nothing. Okay, So think about the situation I was describing where you have, you know, a SQL statement that's thousands of lines long. All right. The set of hints may not be sufficient to narrow it down to a single plan. Right. They may be able to narrow it down to 4 or 5 very similar plans that all perform fairly well. But with baselines, if I don't get the same plan hash value that I started with, it throws all those hints out, and it just goes with whatever the default optimization is. Okay, so it can be confusing occasionally with baselines as to why you didn't get the plan back that you were expecting. And that's one of the reasons that that can happen. All right. Profiles, on the other hand, apply the hints. Whatever it comes up with, it's going to run. So in some cases, a SQL profile can provide more stability performance-wise, even though the plan may not be exactly the same as what you started with. All right. There is a procedure to import plans, but not hints. Right? You have to have a SQL statement in the cursor cache, and you can take that plan and implement that, the set of hints that go with that plan. All right, but you can't just manually type in a hint or a set of hints or pull them from somewhere else. Make sense? They're overridden by outlines, which is kind of weird, but you're not going to use outlines anyway, so don't worry about that. And they can merge hints with patches in particular. It doesn't really make much sense to have a profile and a baseline unless you're trying to do something like move from one to the other. So maybe you've got a plan with a profile that you want to create a baseline on. You can do that and then drop the profile, or vice versa. If you've got one with a baseline on it, you can create a profile on it and then drop the baseline. All right. And here's another big difference. You can have multiple baselines per statement. So if you have a bind variable peaking sort of thing where you've got 2 good plans, you know, one for one sort of set of variables, and another one that's maybe a full scan oriented plan for, you know, non-unique kind of data, baselines can have both those plans, right? Whereas SQL profiles don't have that option, right? They got one set of hints and that's it. And that can be a big advantage, actually. They don't have any categories either, and there is a preferred set, but that doesn't make much sense to me either. I'm on time. I think I'm about done for time, so I think I'm going to break here and to see how the show ends and whether the guy gets caught at the end of the TV show. You have to come back this afternoon. I'm sorry about that, but that's the way we do it around here, I guess. So if you've got any questions, I'm happy to take them probably at lunch rather than do it here and delaying you. I shouldn't be standing between you and lunch, I guess. So grab me, and I'll be here all day. Thank you.